snap in on the
come in.
sponge right below it?
Video, yeah. I think this is what you're talking about.
I wonder if it rolled over from its...
It's like a rock.
Oh. Yeah, it does look like a rock.
It is.
So why is that rock such a different color than...
It's likely tumbled down from above. Yeah.
Okay, video.
It's
definitely not in place. Yeah.
Such a good biologist.
Well, I have to admit, I was hoping it was a Geodia because we've been collecting Geodia pachydermata, a sponge that is being used. Shirley Pomponi is hoping to use it as one of the species that can help us understand
connectivity around the whole North Atlantic basin, basically. And that's part of the Aspire campaign that this cruise is kicking off.
Oh, nice.
Now we're seeing
nice.
This is
Step.
beautiful. The pilot points we'd like the
really cool.
lasers on and also to zoom in under these ledges.
Understood.
Thank you. This is beautiful.
And maybe on the corals as we
all the
pass them too.
If we have to. Yes, of course. I'm sure we'll see lots of organisms living beneath these. That is beautiful.
So Scott France wrote that maybe this is the stairway to coral heaven.
I got stepped on. We have reached our new position.
Wait, did you say G's or cheese?
That too. I should have said cheese.
Okay, video on Chris Gorgia and Wall here.
Oh, lots of burrows in there again.
And then the top layer of rock looks a little less eroded.
Yep.
Oh, and there's a shrimp on the Chrysogorgid again. This one is more planar instead of cylindrical.
Yeah.
We'll go for the geology first.
Looks a little different from the other burrowed rock we saw.
The burrows look larger.
Yeah, they're larger, probably a little more whitish in color, so that maybe it's a little more calcareous material than just muds.
Maybe you can zoom out a little bit.
Squat lobster in the upper right, and then maybe a hermit crab above that. Lots of squat lobsters in the coral rubble.
Leslie, this is really making me appreciate geology.
It is pretty amazing.
It is really cool.
It's very cool.
I don't know how. I love hearing you say that, Stephanie.
Those might be some cup corals there underneath that ledge. And a hermit crab on top.
Are those are the cup corals Bathopsamia or
no? Those look different. And those Bathopsamia would be shallower, more shallow than this. And yeah, I'm not sure what species those cup corals are.
Okay, video, you can come wide.
They have pretty big.
See what else.
What are the ridges called? What's the correct name for the ridges?
Septa.
Septa. They've got some pretty big ones.
That is a beautiful
Desmophyllum-like.
Yeah, Desmophyllum definitely has those large exert septa.
Yes, that's what I was thinking.
Here's a little more massive wall of likely that same material. If this is a calcareous material that has been deposited and then somewhat lithified, maybe not fully cemented together, we would call it chalk.
Oh.
But it's hard to say at this point. If it's fully lithified, calcareous material, it would be a limestone. So there are different degrees of compaction and cementation from these calcareous oozes. And the ooze is the name of the sediment itself that makes this bright white rock we're seeing. And it's largely composed of nanofossil materials, which are microscopic algae that live in the surface waters. They photosynthesize, and when they die, they have very small platelets called coccolithophores that settle down to the seafloor, either individually or more often they settle within fecal matter. As organisms eat the algae, the fecal matter contains these little platelets called coccolithophores. Or, I'm sorry, coccoliths. Coccolithophore is the organism.
The organism, yeah.
Yeah, coccolith is the rock remain, as the name implies. The lith means rock. And that's how a lot of these very, very tiny particles make their way to the seafloor, packaged in these fecal pellets.
Definitely feeling more current here.
And this terracing effect, where it's stepping backward and backward, that tells us that it's easily eroded, and so as it erodes, it breaks off and tumbles down the slope, and you keep getting material eroded back into the rock face itself, into the layers.
Another chrysogorgid in the center there. Maybe we can check out which associate that one might have.
Yeah, video we can snap on chrysogorgia. Go ahead and zoom in video. Yeah, see the guy here.
Looks like shrimp.
Looks like a shrimp. That must be the common associate at this particular site and depth. Another wounded squat lobster in the coral rubble behind the coral.
They always seem to be in the background here. We've seen a lot of them.
All right, video. Come on when you're ready.
Big rocks that have like broken off and tumbled down. But that's exactly what you were talking about, the terracing effect, where like, things are breaking off. And
yep.
And even
I'm learning geology right now.
I've learned so much from Leslie over our dives. A whole different appreciation of the substrate that the corals are growing on that I usually wouldn't pay any attention to.
Well, I'm glad it's rubbing off a little bit. Certainly I'm trying to learn all these crazy names of corals and sponges. I have them all written down, but it doesn't mean I can pronounce them either. That takes some practice.
Good afternoon, pilots.
Hey, Roland.
Good afternoon,
Some more background on the Association of Chrysogorgia and Shrimps.
Yeah.
Scott France pointed out that in the Atlantic, Bathypalmonella ceratopalma is found on multiple species of Chrysogorgia. Tricollis, averta, and abludo. Chrysogorgia.
Do a quick zoom on our sea star friend here.
Yeah, video. Let's try to get this star here.
Okay.
I'll get you closer to reduce.
And Tammy Franks
hold
thinks that actually might be Bathypalmonella that we've been seeing the sponge in the Chrysogorgid. Oh, and we've got a nice sea star.
You come in, partial.
Pushing in.
Bright little guy, huh? You come in more video. Is this the cookie star?
I think it is.
Pretty big, though. Look at the texture on that guy.
Current makes it look like you're working in a hurricane.
Yeah, we are.
We're hoping that Chris Ma will pipe in and tell us what we're looking at. He is our sea star expert who has joined us almost every dive now. yesterday we had a plethora of sea stars for him to discuss and describe.
Is that max zoom?
No, it isn't.
You can go in more if you'd like.
That's max.
I believe this is a goniasterid, but I hate to. And I see that Nolan Barrett, who is now online, agrees with that. It's a large group of sea stars with many, many species, of course.
Jason's commenting about the number of borings in the rocks.
Oh, I'm sorry. I haven't even looked at the chat room enough. I was so glued to the screen. I was missing the comments from my colleagues, Jason Chater and Scott Harris, also, the resident geologist in the chat room.
Right?
And Jason says
it's very brittle.
The presence and absence of borings in the adjacent parts of the outcrops is something we are trying to use to evaluate the, quote, age of the timing of failure along these walls, scarps, and cliffs. No borings would indicate young. Lots of borings would indicate older. And I'm assuming that that would mean if it's all the same type of rock, certainly different types of rock would have different characteristics or boring ability. And I don't mean boring ho-hum. I mean boring and burrowing and drilling into the substrate.
Understood. All right, rolling it. We'll try to go for this gold one here.
It's definitely not boring to those of us who appreciate our rocks.
So I just wanted to zoom in on this one since it is a coral I don't believe we've seen yet today. Obviously has an anemone perched on a dead portion. It looks in the next branch back from that. It looks like there's an amphipod.
I think might be a dust cloud coming.
Is anyone chiming in the? Okay, Scott France says it's a plexaurid of some kind. That's good enough for me.
All right.
And the sea star we
hey,
just
Pilot,
saw,
I think that's good, thanks.
Understood.
Nolan Barrett suggests it could be a plinthaster dentatus that Chris Ma has identified for their group at the Medical University of South Carolina Natural Products Lab.
Do that by bringing
but he's
the
not sure,
down
so we're hoping
in.
Chris. We've sent out the Chris Bat Star. He usually calls in somewhat delayed from when we've actually seen the organism, but it's nice for him to give us an idea on some of these. It's a beautiful anemone down in the bottom.
And then a pretty big pseudo-anthomastus or anthomastus that we just passed on the lower left.
And on the left of the lasers right now. Yes, now we're seeing some ledges.
Geology.
Oh, sorry.
Keep moving toward the ledge there.
Looks like it comes
I'm
up
very glad I have some other geologists on the line.
Nev, when you get a chance, could you just unsaturate the Sirius's sonar a little bit?
Very interesting outcrops here. And as Jason Chater of the USGS suggested, the amount of borings from organisms.
And then just rotate it up. Go ahead.
Give us
watch one.
Sort of a handle on the age of the rock. These are not borings, I don't think, that we're looking at.
Much better.
Got it.
We'll get a zoom
So
into
keep an eye on that. It's been about there for
a
while.
Copy that.
And ship
I think this is Madrepora oculina. We were seeing quite a bit of this yesterday, I believe. We're going to zoom in on it so that we can be sure about that.
And what would you like me to look for there?
Oh, just go straight up between my light bars, and then we'll just leave it up there.
This is really cool. It's like
gives me a perspective up,
straight up and down, and the layers are so obvious and
yes, and you can see the differential erosion, resistance to dissolution or erosion.
Both lowers,
it's a combination of both.
So they're not hanging down so far.
Did we have someone
wall,
calling?
I can turn left and right without hitting.
Hi, Leslie.
Coming on Coral.
Hey, Scott. Great, thanks.
I mean, it's all interesting to discuss, but you know what I mean.
Looks like a carnivorous sponge there in the upper left near the coral.
I think you're correct in that it's a sponge. I'm not qualified to identify whether or not it's carnivorous.
Yeah, it's like a video engineer would be.
Scott, you do agree with that? Okay.
You go back up.
Yeah, Roland's always right. Just go with it.
Go back up.
Yeah.
Let's not go there. That's a video engineering description.
Yeah, in the stove.
But yeah, that has the characteristic appearance of a carnivorous sponge. Fairly thin branches with those little filaments that are coming off the side. Kind of look like a little bit of a feather.
All right, thank you, Scott.
What is that directly below? If you just pan down.
I was looking at this earlier. Oh, yeah, a little. I think that's a lithodid or pseudo-lithodid crab down there. It's got a pale pink.
Interesting color.
With all the spikes on the carapace.
How tall is this wall, you think? Would you estimate?
Can we try some extra
You're
rice?
right, Stephanie. We're probably looking at it on edge or something.
947. 956.
All right, it goes pretty
I'm looking at the sonar feed, and it's just a very solid line, a wall in front of us.
Video come on.
You'll see when we pan
20
out.
meters above you.
Yeah.
He's not seeing over it.
All right.
And pilot, if we could get a face-on view with this scale, with the lasers, and then zoom into these different types of layers.
Yeah, we can zoom into geology.
That'd be great, thanks.
This is quite a wall, watch the.
Yeah.
We got about at least 20 meters high.
Great. Well, after we take a close look, maybe we could back off, get a sense of what it does look like. I've noticed on the sonar how solid it looks.
Lots of squat lobsters hanging out here on the wall.
Watch it, is this the view you wanted to see?
Yes, okay, and then also the layer above it.
Understood, slowly rising.
We may want to have the ship move back a little bit, get me further off the wall to give him room to.
Yeah. So here's a more resistant layer,
or we
so
just
it
come
sticks
up together.
out. And
510.
Or we could come up together.
Yeah.
And this is what you were talking about. The lighter color potentially indicates it's calcareous.
Well, yeah,
material?
We'll have to look, but generally the yellowish bright white is calcareous.
Can you tilt the camera up that way we can see under the ledge?
In the sediments, if it's reflective white, that would be silicious, but we're not likely to see that here.
We've got a lot of different kinds of biology on this geology here. Some cup corals.
Slowly rise.
Over to the left, it looks like a plumarella.
I'll keep a
and then some
Delta
more
Z at 20.
Madrepora oculata. Oh, and then I don't know what this just went off screen. This yellow coral.
It's interesting how densely populated this rock is. It's sticking out a little. It seems to be different. Maybe we could, and then if we could snap on the under part of this ledge, on some of the organisms living on the blacker.
While you're snapping, I'm going to peek up a little bit with the Sirius's HD.
Okay.
Just a good idea.
So what would the blacker rock be as far as composition?
That's a good question.
Okay.
It could be some of the encrusted material that we've seen in so many areas around here, that iron manganese oxide
5 meters back
coating on the rocks, but it's very hard to tell. This is not a fresh surface, but it is interesting how
I can see the top
it is so densely populated by these small organisms compared to the rocks below.
Or not.
So it may be a little more lithified.
Yeah, we got some distance.
We can do a small bump.
Very resistant to erosion.
Just get a 45 angle just for lighting purposes.
And the pitting that we've seen, Scott Harris writes, is often caused by dissolution and bioerosion in the limestones, which certainly makes sense. So it's an effect of the burrowing, and then continued dissolution is likely to round out some of those pit-like areas.
I was just asking pilot if I could zoom out.
Tino was asking to
zoom
in
sort of down
also.
the strike.
You can do that, Roland. Zoom out. I'll turn to my left.
Let's look at this whole area.
Yeah, wow.
Wow. That's what we wanted to see.
After we look at the geology, can we check out this?
Yes.
What were?
You're talking
I said, yeah.
This. Yeah.
Consulting the geologist.
Rotate to the other side.
Sure. So a pilot at the base of the cliff over on the lower left of the screen is
something white in color.
A white color.
Yeah.
Copy.
Organism.
I saw it before. I was just being patient for the geo. Well, I like this wall too. I just.
And as you go there, if we could continue to look way off to the right.
Oh, we're going to look at this, Roland. I can do that after this. I can look to the right after. Yeah.
So you can imagine how if a piece of this rock were to break off, it would tumble quite a distance. So we were seeing some of that earlier.
The molted shell. Molted, yeah, and then there's some things coming in to feed on it.
Lunchtime.
ROV nav bridge.
It looks like complete. It might actually have been a failed molt or just a dead crab. I guess it could be. Oh, it looks like there's actually some animals inside feeding on it, maybe. All right, back to the geology. I just wanted to see what that what was.
Well, pilot, we can climb slowly. That'd be great.
Yeah, absolutely.
So our depth right now is probably the base of this scarp area, or this cliff, is probably about 946 meters, and we're rising.
See some bathypathes on the wall, madrepora. Oh, there's a really, look at this, really big. Actually, that might be what they were talking about earlier, the telopathes. Scott and Tina, what do you...
It does look like telopathes from a distance.
It does? Is that...
Yes, it does.
Okay, just making sure I heard you right. Okay.
Basically, a telopathes looks like a large branched bathypathes.
Yeah, go ahead. Yeah, come in video. Is this the one you're talking about? I think, yeah.
Exactly, thanks.
Understood.
Wow. Big, healthy-looking colony.
You're falling backwards.
Because it's on this nice, steep ledge or wall, I should say, right in the current, and you can see all those particles going past. And that's the exact stuff this coral is feeding on.
They get closer again.
Nice anemone above it.
Yeah.
Beautiful. Large one.
Yeah.
Well, actually, did you need a closer look at that subject, or would you like me to keep coming out?
No, that was great.
Understood.
Thanks.
So have we determined if these coral groups are madrepora or are they Lophelia? I think Tina had thought they might be Lophelia.
I thought the orangish ones were madrepora, but maybe we can get a look.
Yeah, go ahead, watch one. Yeah, let's go ahead and snap in video.
I can't hear what she was asking
There's
for.
a nice
pale
protruding rock there.
Oh, and this one too.
This is a beautiful view.
So we get 2 for 1.
So there's some Lophelia.
Yeah, the white is Lophelia,
so she
correct?
must have been referring to
that.
She just hadn't been in the view when
yeah,
I
it might
saw
be
her
a delay for her, so she was referring to. And then
try not to drift away on your own.
Scott, what's this yellow coral to the left?
It looks like you're starting to see the top.
I'm not sure what species, but almost certainly the genus Acanthogorgia.
Yeah, we can start seeing
Okay.
a little bit behind it with the
barnacles.
Yeah, it's got barnacles growing on it. And pilots, watch one.
So this is the madrepora.
Yeah, can we just scan to this? Yeah, to this coral.
Understood.
That'd be great. Thanks.
Yeah, co-pilot, your altitude is like 35, so
lots of anemones on the.
Approximately.
I love how the
meters.
anemones live within the corals like that.
It looks like
one
there's
of our
a
bryozoans, the white, lacy looking. We made a collection of that earlier in the dive.
Nolan said he's seeing a geodia. I didn't see that, but just possibly too busy looking at the sponges or on the corals and the things living on the corals. Now there is a squat lobster on this Acanthogorgia.
Yeah, I'm not sure what your position is. It looks like it's kind of currenty, but this could be a good target for a collection given the various associates on it. The Acanthogorgia, I mean.
Okay.
Yeah, I overheard Scott France. We're not in a position to collect this. I think there's too much current. I can't. I wouldn't be very stable here, unfortunately. Yeah. All right, video come wide. We'll keep moving up.
Oh, so maybe the geodia is down here?
I'm not sure actually what he was referring to.
Does that rotate right?
Yeah, I can rotate right for you, Roland.
Looks like another telepathes.
Gives us a wider
right
sample of
where the lasers are passing by. Oh, there's a bunch.
And also lighten up
this wall is quite massive compared to what we've looked at. The other layers below it, these are much thicker layers. It's still hard to tell what it is because it's covered with actually sediment and organisms.
Just watch
see
your,
a little bit of
port light
ledging there.
Your upper.
Okay. Thanks.
So we've got, Lophelia, Madrepora, telepathes. So there's a vase sponge. Large anemones.
All right. Go ahead, watch one. Yeah. Go ahead and come in. Partial video. Watch these. Is this the subject here? Coming center?
Copy that.
This coral? Understood. Come in video.
I guess that actually looks like a plumarella.
Do you need a closer? I didn't see a response in the chat room, but I had made a note earlier to Jason that what I'm seeing here looks a lot like some of the canyons that we explored up on the northeast coast of the U.S. back in 2013 and 2014. And associated with that, I noticed we just passed a little sort of cave-like feature, an erosion pit, I guess. And certainly in those canyons, when we saw those, they were very common places for octopus to be hiding out, often with brood in their eggs. So it might be worth peering into some of those features if we come across them again.
That I would love to see, for sure.
A lot of current here, and I have to be broadside to it.
Yeah, you are doing a great job, though, especially with everything going on.
My breath was taken away when we pulled out of on that view.
That is not something you get to see very much. Just such a straight down wall.
And when you just think of, we've been rising, we are now, I don't know how many tens of meters at this point.
Oh yeah, we're at like 915 right now.
And when you think of the amount of time represented in these rocks, the very, very slow buildup of sediments on the seafloor, they get buried, they get compacted, the water gets squeezed out, and then the water between the particles gets solidified or crystallizes into a cement, binding those grains together, and that's the process of lithification, is what we call it, to make a rock. And so we're seeing the results of that, and they represent millions of years of geologic history. Perhaps these rocks, Jason Chater of the U.S. Geological Survey estimated that these rocks may be of Miocene age, so we're talking 10 million years old, and maybe not these we're looking at, but possibly at the base of this area. And so a tremendous record of of climate is stored in these rocks, actually. If you look at the microfossils, which are indicators of climate because they live in the surface as living organisms, and their shell remains settle to the seafloor to capture that climate record. And these are the edges of the layers, many, many layers, and we are on the outer edge of the northern portion of the Blake Plateau, and these water depths begin to descend rapidly just east of here in a feature, a very large feature we call the Blake Escarpment. And on our very first dive, I can't even tell you how many days ago it was, but last week sometime, we were on the Blake Escarpment at a depth of about 1,700 meters.
So good, Nav. How are you doing?
Just around 1,000 meters is where we started our dive today.
Above this cliff now.
And we're currently at 925. So this has been a significant climb. We were estimating a 100-meter
huge
scarp,
coral to
and
your left.
much of that scarp is vertical, is what we're finding.
Wow,
this is beautiful.
Okay.
Now that takes a very solid rock. Look at the the base of that.
Paragorgia?
Amazing.
If we can get it from this angle first before we rotate to the other side of it.
Copy that.
Yes, this is definitely a Paragorgia bubblegum coral.
And this is perhaps the first we've seen. I don't know if we've
today at least. I think we
certainly
haven't seen.
Today, did we see them?
We collected one on the the first dive.
Just not in a while. We haven't seen it.
But we definitely collected one. This one looks like in a pretty precarious position if this wall is eroding, but obviously it's been here long enough that it can grow.
Not today, but
many, many decades, if not more than 100 years.
More than 100 years old, you think you said? We're switching shifts. I couldn't quite hear you, Scott.
Yeah, Leslie, I was saying, given its size, I would guess that this is at least many decades old, if not more than 100 years.
Beautiful.
Nav, co-pilot. The ship's not moving, right? Copy that.
Are the fog lights on?
No.
Wow.
Let's,
can you range in the sonar?
Yes.
On level?
Do you want
20.
20, copy. Yeah, so Dan, you're about, I think, in the middle of this wall. Sirius is peeking over it now.
Okay, and he's 20 meters up.
Yeah.
Okay. We've been climbing this very vertical face for over 40 meters.
Let's get the swing arms in.
Copy that. Lowers or uppers or both?
Both.
Copy that.
Everything else okay?
Even on this vertical face, you can see that it steps back slightly with different layers. Yes. Yes, the first one of this dive, and we haven't seen it since we left the edge of the Blake Plateau, I believe.
Yes.
All right, Sean. So I just want to confirm your turns.
Yeah, so we believe D2, when Finn shut down, got a positive turn. And then
Pilots are also stowing the light bars so they can get in closer to this cliff without breaking the light bars.
And it's been fine since it's happened, and we've been checking on it. So we want to, but that put a turn in the 6-8. So before we come up, we want to put a negative turn in the 6-8, so to port on Sirius.
Okay.
And then still recover with a negative turn in the neutral tether.
Okay.
Which is what we have.
So
right now.
-1 turn on D2.
Yeah.
And then leave Sirius where it's at for now, unless you want to
for
take
now,
the.
Yeah.
Okay.
And then, but before we come up, we talked to Bobby. He does want to take the turn out of the 6-8.
Okay.
But yeah. Good so far.
Some sort of gelatinous pelagic material just went by our camera. Fortunately, Stephanie just went to lunch, so she was not able to help us identify it.
Normally, it'd be okay to have a mount, but not in this current. This is very strong, and if we lost a motor and got swept away, we wouldn't want to have those out.
This location is still very much
let's just give you
under
visual
the influence of the Gulf
right
Stream. We're far enough north. We're off the coast of Charleston, about 190
down
miles.
in order to try to give you a better view.
This is where the
fine.
Gulf Stream begins to bend eastward.
Video I can try for the uppers. I can try
it does start to bend
them up
eastward.
and down.
And part of that is due to
it won't help as long as we're
the
reflecting
impact
light
of
off
the Gulf
those
Stream on a
particles.
feature known as the Charleston Bump, which is closer to shore from where we are located. And there was an expedition in 2003, I believe, 2003 with ocean exploration, not on the Okeanos Explorer. I was a part of that expedition.
So I guess our best bet is to get as close as we can to it.
Yeah, I'm not going to be able to get too close to this, Roland.
In those days, so we use submersibles,
laser that base,
which under the Gulf Stream is probably the better option if it's possible.
I don't have a whole lot of range of motion here because I can't turn out of the current. I'm already like
the ship, and we
close to maxing out the thrusters.
Yesterday, and had to miss several different proposed dive sites because
towards the cliff to sort of give you more of a reference
ship's
point.
Position being difficult to maintain in the current while the ROV is at depth, and the ROV is tethered to the ship. So, in high current situations, it's probably a little
zoom in
better
from here.
to use submersibles if it's affordable.
Hold that.
Oh, that's beautiful. So these are nicknamed the bubblegum corals, Paragorgia.
Lasers are clear at this point.
Okay, turn off lasers.
Still need to laser the base later if we can.
Lasers off. So this is Paragorgia bubblegum coral. Probably Arborea is the species. And I think this is the first one of the species we've seen this expedition. Looks like it has ophiuroid brittle stars.
The branches, the characteristic astroschema brittle stars that are often associated with the Paragorgia.
So it's we got a be on our A game here, guys. A lot of current right now.
No, that's the ophiuroid.
And we're on a wall.
That's the one that's an ophiuroid.
You can see him up here too.
Oh, he looks much more like a worm when you just see a portion of it. Huh. So there are other brittle stars here as well, I assume, then. Or is that the end
figure
of
out
those?
What would happen to the ship if we started to drift with the current at the surface?
I think there might be two different types,
we would
possibly.
Drift from northeast.
Okay.
Well, more east than north.
It's in a good spot to capture food particles.
Okay, let's come out.
Very impressed by the base
like
of that
coral. This is an old coral.
Yeah, it's beautiful.
You can get lasers on.
Coming on.
And it looks like Selenus milia is the coral scleractinian growing on the wall here.
We haven't seen that in a while, right? So that's a little more characteristic of the deeper waters, perhaps?
Yeah.
Rotating to check the turns.
Astroschema is that ophiuroid, the one that looks more worm-like.
Now, these rocks are much more erosion resistant than the earlier layers we saw that made much more of a stair-step like terracing. These are much thicker, massive rocks of, I'm guessing, limestone. Won't know until, if we could get a fresh piece, but I certainly won't advocate getting a rock sample here. We hope to be able to get one at the top of this ridge, or scarp, so that we can look at the boundaries of age. We got a rock sample near to the bottom, and hopefully that will be able to
might be a
provide
step,
some age dating for us. And we
might
could
be
get
another
one for the top.
cliff face potentially.
Define the length of time that all that material was deposited. Millions of years,
okay, I'm
without
rotating
question.
up to 4-5 pilot.
Copy. I'm going to scout ahead, see what I can find, and then we can maybe get you a little bit closer to
We may
V2.
find at the top
Copy.
that if the currents are like this, that it's still
this is the bridge
low enough current to have a lot of sediment, so we may not find the rock exposures we
Yes, I have the bailout
are
to east.
anticipating.
We are in present position.
More of those
We have
bryozoans.
the current directly on the bow and the wind just slightly on the port bow.
So there's certainly a characteristic
the current is the
species of
stronger
this
vector right now, and
dive and
everything's very
habitat
balanced and
today.
holding well. Thank you.
All right, Fernando, can you range the sonar out again to 30 meters?
So much of some of the canyons that we dove on, and having that Paragorgia up here even more reinforced that. Many of the different fauna that we saw there, very characteristic of some of the canyons.
Right. And I was thinking that this nepheloid layer that we're in is also kind of characteristic of the canyons.
Yeah, Cheryl, and I guess that's partly a reflection of the
ways,
depth that we're at and the depth of the canyons that we often explore.
Yeah,
so
I'm
that's
thinking
gotta be
like,
tied together
let's do 15 meters towards D2.
Copy that.
I don't know if this
So
is a
270.
Liopathes that I see in the distance, but there's so much marine snow
I'm going to come back down
it's
a little bit, Andy.
tough to see very far at all right now.
So it looks like we are at the top of this feature.
I don't know if it will step again, maybe?
It looks
well,
like...
that was the dive track that we would cut across this area, and then it should rise up again. So this is the top of that first wall.
Okay, 15 meters, bearing 270, speed decimal.
It definitely is not a lot of clean rock exposed for coral and sponge.
Particulate in the water too. You want to try turning off one of your light banks?
Actually, one of them is a black
help
coral.
Improve visibility, like the middle one, yeah.
And in terms of habitat with these deep corals and sponges, we often say they need rocky substrate, but the other thing is that they need clean rocky substrate, and so often higher sloped areas provide better habitat because the material that is settling through the water column doesn't stay on those ledges, and the other factor would be the current. So the rocky substrate or a solid bottom type to be able to attach to a current flow for the food particles, and
it's almost as much
either
as
strong enough current so the sediments don't deposit,
I remember
or
seeing
a
these in
sloped surface
in the Pacific.
like the wall
we
we
were in the middle of a volcanic crater, and the visibility was similar.
An area that
maybe you could turn on the auxiliary lights on D2.
So there's sort of
a
balancing act of those three variables. And then, of course, the depth range and the temperature that will determine who is living there. But we definitely see an increase in populations and
LED upper and LED
diversity,
lower.
where we see a combination of clean rocky substrate, which is often on high velocity areas or sloped areas.
I think you're too far away from it for the lights.
The white colony just to the right of that. I think that might be.
Okay, it seems like they're not yet on.
We're just trying
Did you hear that, pilot? Would it
maintain visual contact?
Go ahead, Ashley.
Yeah, the other coral to the right, and then there's a white one to the left of the bathypathes we're observing. Thank you. Is that more of the plumarella?
Like Fluorella, which we also saw on day one.
Right.
Unless I'm just looking at a plumarella on the side, I don't think so.
No, I think it looks like plumarella.
Oh, you think it's Flumarella?
Yeah, it looks like it to me.
Okay. Okay, maybe I was just fooled by the angle. Thanks.
Yeah, come out rolling. Let me get situated here.
At this closeness, you might try those extra lights.
So go ahead and try again. You can zoom in.
There's a better view, Scott.
The fog lights video?
Yes, please.
Yeah, certainly it's plainer. I think Flumarella more typically comes out like a bottle brush each of the branches, so.
Okay.
That's good, thank you. They're both in the same family.
Brings out much more color, but it doesn't really help the washout.
Yeah. Okay, let's come out. I need to kind of get situated here.
The lights are clear.
Oh my gosh.
That is for sure. We were wondering what the object is that's kind of on the bottom of the view now.
The white one?
Yeah. Don't know if it's debris or whether it's like the base of a coral that's now dead, or
so we're stationary right now.
Looks like correct. A rawhide I'd give my dog.
ROV nav bridge, move complete.
Go ahead and zoom in.
Move complete.
Okay.
Yeah, so they
I think you could do another.
Came to stop.
Yeah.
Is it a rock? Or an old bone?
15?
Yeah. How'd you feel about another?
Yeah. I'm looking at you at 40 right now.
Okay.
Okay, 15.
15 meters, yeah, 270.
Copy that.
I would agree it might be a bone, but it's not a rock. Interesting. Seems to have some worms that have burrowed.
This bridge over.
Bone looks like a chip is out of it there.
They're bone-eating worms.
Okay, 15 meters, 270 degrees.
It looks like a chip out of that.
Yeah.
Somebody having chomped on it. Hard to say.
Come out. Sorry.
Interesting.
Yeah.
Doesn't look like it's been very long. It doesn't have very much growth on it. And if it were a bone, it wouldn't last very long in this environment. It would be consumed.
Can I go in again?
ROV nav bridge, move initiated.
Copy.
Doesn't look like wood. It's too bright to be wood.
Copy.
There are folks in the chat room agreeing that it might be a bone as well.
Sako Matsumoto says, we need a microscope. That's the next evolution of deep sea exploration, where we can have a microscope affixed to the ROV.
Okay, video's clear.
Okay, you can come out.
Full wide.
Oh, that was interesting.
And will remain unsolved as a mystery.
There's a couple more black corals coming up here.
And Nolan Barrett wrote about that potential bone, that the grooves remind him of where blood vessels would vascularize the bone.
Any interest in anything here? Watch lead.
Look at the end of the bone.
Sure, if we could zoom on the black coral that's towards the back, the orange one.
Sure.
Thanks.
And Jim Masterson suggested it was a lower jawbone from a toothed whale with a question mark.
Huh.
Interesting, because we saw beaked whale marks deeper on the Blake Ridge in the sediment areas.
Turn your head to port a little bit.
Where they had plowed
looks
into
like the auto
sediments
heading's a little offset.
Yep. Coming around.
Thanks.
I thought this was a black coral from further away, but now that I'm looking closer, it's definitely not a black coral.
There's another of the fuzzy white ones to the foreground left. And as we get closer, that's just telling me that there may be lots of these upstream nodes that are just hard to see from a distance.
Yeah.
Okay, you can go in, roll on.
This one looks like it has some anemones on it. It's got this looks like a plexurid fan.
Yeah, so it's quite possible this is a Paramyricia in that genus or a closely related one. It's kind of hard to tell from the video. But definitely in the family Plexauridae, which is a pretty large, diverse, and common group of sea fans in the deep sea.
Okay, you want to come out for a specimen shot and get lasers off?
Can't quite tell if there's tissue missing, or it just seems darker along the branches where the polyps are rising. Kind of an interesting color pattern.
Yeah, and then there's I don't know, 3 or 4 at least anemones on this colony. So I imagine there's not any tissue there.
And the one thing that I'm taking note of is that there is no brittle star on it. Very often there are several species of Paramyricia that are commonly associated with a brittle star, and this one does not have one, and nor did the last one we looked at.
Huh. This poor hermit crab has a gastropod shell that also has barnacles, and it looks like a serpulid tube worm, maybe.
Go tighter.
He's carrying around a lot of extra weight.
Yeah, that's just piling on there.
Yeah. Poor guy. That's a very tiny octocoral that he's climbing on now.
You have to consider that that's a badge of honor for that crab.
Yeah.
Probably also says it's time for him to find a new shell.
Yeah.
Okay, that's good.
I'm sure he's in the housing market right now, calling his realtor.
Move up slope and push a little bit ahead, Andy.
Copy that. We might put another move in.
Okay.
Well, let's let me take a peek here and make sure there's no more steep faces coming up.
Okay, I'm not headed at 4-5. I gotta.
And Andrea Quattrini wrote
250
that she thinks that these large yellow plexurids are Paramyricia, but she said, of course, they're Acanthogorgia as well.
So I'm pretty close to 270 now. Okay. My rotator's at 4-5.
Okay. You can go ahead and come up in altitude a little bit.
Copy.
And Tina found that the genus she was looking for, Phanelia, and that can also be flat and pinnate, like the what we've been calling Plumarella.
Can we try and experiment and turn off the upper center lights and see how just the outer light bars light for us?
So you want to turn off the upper swing arms or the main banks?
Main bank. Just try to get the light further out than right in the direct center. So whichever ones at the moment are further outboard.
Oh, look at
What
this.
is this? Is more bone?
Looks like it, huh?
Boy.
So the upper swing arms are in the center, and the main banks are
Goodness,
outward.
that's a much bigger
bone. In this case, I'd say close all swing arms, just as a test. See if it reduces.
And there's also a giant.
So I think we may be looking at a perhaps giant base of a Paragorgia.
That actually looks.
We saw earlier that we
yeah, you see.
May have been a giant piece of Paragorgia skeleton. And that would explain all those pits.
That's
I think this is a coral skeleton.
Okay. It could be a coral skeleton.
You want to get lasers on?
Yeah, if we can get a zoom in.
Lasers on.
Gosh, that would have been a huge colony.
You can go past the skid rolling.
Maybe that's what we have in store for us.
I hope so.
Coming up to the next scarp.
So Paragorgia, Paragorgia, the bubblegum coral we saw earlier growing off the wall.
So the ship has stopped, right?
Yeah, I'm pretty sure.
What do you need, Roland?
We'll start off with the part closest to the vehicle.
Scleraxonia.
You want lasers off now?
An internal skeleton that's very different from, for example, that yellow sea fan that we were just looking at. If you were to scrape away the tissue, as we've often seen has been done by various organisms, you would see a very distinct internal skeleton. It would look to us a little bit like twigs of wood on the branch of a tree, but it's actually made of protein.
And what would happen if we turn on that,
corals and other
what you guys
call
don't have a solid internal skeleton like that.
How do you like that?
Instead, you can think of something more like concrete, where they have lots of small calcareous spicules, kind of like grains of sand, that are more or less glued together, intermixed with the tissue of the colony, so that when it dies,
it
erodes much more easily than do the sea fans and all, for example, the Lophelia skeleton that we've been seeing. Those stay in situ for much longer. That's why I think that might be what this is, also based on the fact
slowly
that
going all the way up.
Base, and there aren't too many things.
Sure, I just got to make sure my footing is good here.
Right.
And why I think that previous one was
a lot of current.
part of the Paragorgia.
And you can see the little pores that we were seeing in the other, what we thought was a bone, down below.
Right, and many of those little pores would be where the tissue, the live tissue, is growing through the skeleton of a
there.
coral.
Yeah, you can see it
Bridges
there.
Nav, our move is complete, and stand by for next one. Yes, thank you.
Looking at the area on the upper right.
The visibility just comes in waves.
Yeah.
It like clears up for a few minutes and then it gets really cloudy again.
Continue upper right.
You want to go tight here?
That is
yeah, it sure does look similar to what we just saw previously.
Actually, why don't we pull out at this point?
Okay.
Kill the fog light.
So you want to wait till we get full wide? So if the editors want, if they want this shot.
Yeah.
Does it change halfway? It's just massive.
And one more time with lasers onto that zone.
Pilots, this is watch one.
Go ahead.
Never mind. I just wanted the lasers, and there they are. Thanks. Yeah, so get an idea of the size of this. It's rather massive.
And let's zoom to that section there. It's okay.
Stand by one. Let me make sure that I can keep my footing here.
We're
so you can see how much current there is.
Tons of marine snow flying by also.
I've been watching your thrusters.
Yep.
That tells me how much.
So this would be a very good place for corals to live, with lots of food being delivered. Oh, and it looks like a little squat lobster maybe, and possibly even a colonial tunicate on the left side there, and upper right.
Okay.
All right.
Let's see what else they might want. Get that sponge thing on the left.
There's a sponge. You want to go to this one that I'm already pointed at?
I was just looking at the one on the left with the balls.
Oh, I see. I got you.
Just taking note of it.
Gotcha. Do you want to go tight on this one since I'm set up?
Go ahead, watch one.